So I really want to make sure. So what is x? So it's really where you want to start always. What does x represent? Yeah. Original price. They say after a 22% price reduction, the price went down by $264. Right? So can you phrase it in the form of a percentage of something is something? 264 is 22% of X. Kick ass. I mean, do you guys see that? The 22% reduction, and they took it down by 264, those must be equivalent to each other. 264 is 22% of what it was, because that's how much they took it down by. If you can rephrase, I'm not saying every percent problem can be done like this, but if you can take a problem and rephrase it like that little what, some percent of what is, then you can just turn it right into an equation. What does this equation look like? Kick ass. And then you just divide. What is that? Yeah? You guys get 1,200?
Yeah.
Okay. Maybe. So, let's take a step back. So this sheet is supposed to capture the kind of problems we've done so far. Good?
Yeah.
All right. Go back to the very first problem. It's about cutting some rope. So what's the very first thing I write down?
50.
No. First piece. Second piece. Third piece. Even if it sounds weird when you accumulate, just use the exact same words the problem does. You can always go back and see the relationship. So the very first step of word problem, you can draw the picture, but if you want to draw some rope, you feel free, but it might be wasting time. So if the drawing makes sense, draw it. Next step is write the English of what's going on. And now I got to translate it into Mathish. Which one is going to be just X? Yeah, look at this. Second piece is shit to do with the first. The third piece has got stuff going on with the first. The first piece seems to be the most important freaking piece. I'm going to call it X. Now the second piece is twice as long as the first. And the third piece is 3 meters longer than the first. X plus 3. Now I'll never forget, real quick. The first time I did a problem like this, I think it was my first semester teaching. Somebody in the background, I'll never forget this guy. He's like, hey, Mr. Waller, I'm a carpenter. I think the problem was a piece of wood. It's like, you lose like 1/8 of an inch of wood in the teeth of the saw. No, you're not with me? When you cut, have you ever seen somebody cut wood, or you cut wood?
Oh, yeah.
I'm like, dude, we're gonna use lasers on our problem. But it was a beautiful example because almost any equation used in mathematics cannot introduce all of the variables in a problem. You see what I'm saying? So we have this idealized problem we solve, and we understand we're going to be a little off because of stuff like that. I mean, the weather is a huge one for that. So yeah, we're using lasers. And then you're like, no, use an 1/8 because it's going to burn off. Oh, shut up. Stop it. So what's supposed to happen with these pieces of rope? Yeah, if you add them back up, assuming we don't lose anything, they're supposed to make 59 meters. Yeah. All right. And now you got a beautiful equation. That should be the easy step. And what again? X is 14. So you come back up here. X is 14 what? Meters. So the second piece is 28. Right? Twice that, right? And so the third piece is 17 meters. Kabam. How do you check this shit?
You plug it in. I don't know.
I like it though. I like the enthusiasm. What are they all supposed to do? They're all supposed to add to be 59. So you just, I got you. I'm with you. You're just such an easy target. I couldn't. I had to do it. Sorry. Thanks for playing. All right. Yes, you're good? Stretching? Ooh, look at that. We got so much time left. Do number 2. I'm pretty sure we did one like this before. I will tell you, a really good idea is to draw this sucker. Rectangle, that's right. Say again, sorry? Oh, here, I'm going to drop and stuff. This one? You need to see it? Okay. Oh, well. Did that show up? No. You know, whenever you look at a completed thing, it's really hard to see what came first and where did it go, right? But the first thing was the English, second thing was the definition, third thing was the equation, and the last thing was solving it completely. Give me all the parts of the answers. So here, if I draw this picture, got a nice rectangle. What are the two players? Which one's just going to be a single variable? Yeah, the width is 9 yards less than the length. So I got to call the length something. What do you want to call it?
L.
Sure, let's call it L. Are you wrong if you call it X? No. You can call it frickin' happy face. I don't care. It's just got to be a symbol that represents an unknown. So then the width, like somebody I think just said, is what? Yes, don't put 9 minus L, because that leads to negative side lengths, which leads to black holes, which leads to the end of the Earth. So can we be careful? L minus 9. And of course, we talked about this specifically. The mistake people make is they don't go far enough. How would I label this? This side is the length, L. This side is L minus 9. This side is L. This side is perimeter. I have to go how far? All the freaking way around. So if I start here, I go L minus 9 plus L minus 9 plus L. Now I've gone all the way around. And that's supposed to equal what? 66. So to be honest, the biggest mistake I see, see if I can get everybody caught up. The biggest mistake I see is somebody reads through this and they go, oh, I see algebra. There we go. There we go, Jeff. Next. All right, that's shit. How many sides have they got in their equation? 1. So you want to make a rectangle so that we can house these dangerous creatures. And what do? You set up a side. We're going to put the creatures in, and they're going to go, oh, cool, let's go around and eat all the people. Bad. This is bad. So your equation has to actually make physical sense. That's crazy, isn't it? That's good. So do I see 4 sides? What are you going to do, Jeff? Yes, I see 4 sides. So it makes sense. So then now it's the easy step should be. I see 1, 2, 3, 4 L's. 9 and 9. Let's see if Jeff made a problem that works. I think I did. I'm going to do this a little fast because this is old news, right? Does that look good so far? Yay. So L is 21. 21 what? Yards?
Yards.
And then the width is 12 yards. Bam. How do I check it? What's 21 plus 12? 33 doubled. 66, yeah. Okay, I like it. How much time do I have? Ooh, I got 2 minutes. You give me that face, I'm going to definitely do some more shit. I just want to tell you, that problem is done, right? You can always do the problem that way. It's beautiful. It's beautiful. Here's what I do. I would take this problem, and I would say L plus L minus 9. Now, if I do L plus L minus 9, how far have I gone? So that equals 33 then, right? Half of 66, 33. Do I get the same answer? Yes. Of course I do, because both equations represent the same thing. If all the way around 66 and I have another equation that goes halfway, it's 33, of course they're going to be the same answer. They both represent the same picture. So as long as your equation makes physical sense, it should end up at the right answer, which means there's multiple ways to write an equation because they can all have the same physical meaning. That might be too freaky, I don't know. All right, so we'll finish this one up next time. That's enough for today. Uh-oh, which one?
The other way.